Welcome back! In this video exercise, we will cover the 2D sketcher and ligand alignment. Let's get started. Make sure you have your Maestro intro project open and your working directory set to your course folder. To begin, let's duplicate the ligand. We've included this ligand in the workspace and we'll make it a new entry so that we can modify it while leaving the initial structure unchanged. Come to the entry list on the left, select CDK2 prepared ligand, right-click on the ligand entry and select Duplicate as ungrouped entries. This will create another copy of your ligand in your entry list underneath the other entries. As this entry is our copy, let's give it a new name. Double-click on the entry name and type ligand underscore 2D sketcher. Then type enter or click in a blank area of the entry list. Your copied ligand now has a new name. As with the names of files and projects, it's good practice to avoid spaces in structure names, as this will make it easier if you export this structure and use it from the command line. Now we're going to use this 2D sketcher to make edits in this molecule. Make sure to include your new ligand in the workspace. Let's come up to the top left and choose Edit from the menu and 2D sketcher. This is a traditional sketcher that you may have used elsewhere and gives you a nice 2D representation of the structure that is in the workspace. Let's make some edits to our 2D molecule. Creating new molecules in the 2D sketcher can be very useful during ideation campaigns. First, let's add another nitrogen to the pyridine to make it a pyrimidine. Click on the N in the lower left of the sketcher, then click on the carbon to alter it to a nitrogen. Alternatively, you can hover over the carbon that you want to change and type in on your keyboard. This works S for sulfur, O for oxygen, and so forth. Let's add a terminal alkyne to the isopropyl group. We will do this by clicking on the bond in the upper left and adding the extra bonded carbon to the ligand. Then click on the bond twice to make it an alkyne. Similar to the keyboard shortcut for atom types, we could also add the bond, hover over it, then type 3 on the keyboard to make a triple bond. Now you may notice that this looks pretty inaccurate for what the angles of these bonds should be. You can click on the check mark in the 2D sketcher, and it will clean up the structure by adjusting things to reasonable bond lengths and angles. From here, we want to save this as the current entry by clicking on Update Entry, not Save as New. Had we not duplicated the original ligand and renamed it, we could have just clicked Save as New. Now we can come up to File and save a screenshot in case we want to add the molecule we've edited to our notes. You can also come up to Edit from the preferences of how the 2D sketcher looks or input a structure from a smile string. From here, exit out of the 2D sketcher. Now we have the three-dimensional version of the molecule we just sketched in our workspace. Let's overlay this molecule with the ligand that we split out from the CDK2 prepared structure. Use Control-click to include the original ligand and your new one. Also, make sure both ligands are selected in the entry list. You'll see why in a second. Double-click on Presets to change the rendering of the new ligand. As you can see, these two ligands are not perfectly aligned. Come up to Tasks in the top right. Type Align in the search bar. This will show you a list of the different alignment options available to you in Maestro. Let's choose Ligand Alignment. You first need to specify the ligands that you are looking to align. Since the ligands are both selected in the entry list, we can stick with the default. Now we need to choose between automatic or user-specified selection of the reference ligand. With automatic selection, the panel will pick one or multiple reference ligands, depending on the number of congeneric series in the dataset. With user-specified, you can choose the reference ligand. Here, we are going to choose user-specified and set the reference ligand to CDK2 underscore prepared underscore ligand. You can define the common scaffold as the largest common Bemis-Merkos scaffold, the maximum common substructure, or a SMARTS pattern of your choosing. You can select atoms out of the workspace to create your SMARTS pattern. We are going to use maximum common substructure, or MCS. Since the ligand is in the bioactive conformation from the crystal structure, we do not want to sample the reference ligand conformation. Make sure Overwrite Existing Entries is checked and click Run. Once the alignment is completed, make sure to Control-click again to include ligand_2D Sketcher. Since we are done with aligning structures, let's close the ligand alignment panel. Now you can see that the alignment is much better. Click on the plus in the bottom right corner of your workspace configuration toolbar. Choose Tile to visualize your structures in the workspace side by side. We can also easily untile. Now that we've aligned the ligands in the workspace, we can bring the protein structure back to see how our modifications to the original ligand might affect how well the ligand fits into the protein pocket. Include the protein structure in the workspace and type L to zoom into the ligands if you haven't already. It is very important to remember that this is not an accurate or rigorous way to evaluate how well a modified ligand will fit into a binding pocket. Visualizing a modified version of a known binder in a binding pocket should only be used to give you a crude sense of possibility of your design fitting into the binding pocket. However, just to be clear, the conformational search, scoring function, and post-docking minimization included in the docking protocol lead to predictions that are considerably more accurate than simply overlaying ligands in the binding pocket. We hope you enjoyed this introduction to the 2D Builder and look forward to seeing you in the next video, where we look at the 3D Builder.